have to do it one day.
The house you are living in is it your own house or?
Correct. The landlord is selling it.
It's not your own house.
No, we rent it.
Oh, so now you are buying your own house.
Well, we have to because the landlord is selling the house, so we can't stay in it.
You can just do that.
Yeah. Now, you can't just kick someone out the next day. You have to give them notice.
Yeah,
so
like
he has. Well, for us it's 7 months.
That's fair.
Because it depends on how long you've lived there. So we've lived there 10 years. So he has to give us 7 months notice for us to move, But have to meet with this person, have to meet with this person, have to go to this place, have to go to the bank, have to call the solicitor, have to go to the bank again. It takes a lot of time and energy, but it's worth it in the end.
Yeah, you have your own house.
Yeah, exactly, yeah. So we're happy because yesterday we saw the place. They were building new houses in Kildare. You know where Kildare is? You know Kildare?
Yeah,
Naas, yeah. Where you work?
Oh,
close to my house.
Yeah.
Close to my work.
Yeah. So Kildare, they have new houses. They were available to buy at 4 o'clock yesterday, and they were all sold by 4:30.
Oh.
So how much was the price like?
130,000. You think that's
cheap?
Yeah,
Yes.
That's cheap.
very.
well? That's why 4 o'clock for sale, 4:30.
How do we know that
Also-
they are like? Do you know any websites like you did like news about the houses?
You want to buy a house?
No, it's very difficult. You have to look at different websites. You have to call people.
This thing was very nice. In fact, like 130 is fine because in Dublin it's so expensive. Like it's more than
Yeah, it's more than 300.
300.
It's ridiculous. Ridiculous.
And then it's okay if you buy a house and then you get it on rent, you will get good rent, good money.
Yeah. So
130 or 3.
yeah, it was.
And Naas is not that far. Like if you have a car or.
Now we'll take the train.
Yeah, even the train. Fine.
The train goes to Houston. You know where Houston is? The train station.
I'll tell you what. Yesterday when we were coming from
The park.
Yeah.
when we finished the park,
Yeah.
big light, something like
Yeah.
before we go to the sea, the river.
Yes.
Yes, correct. Yes, at the end of the river. Yeah.
But it will take. If you would have bought there, it would have taken time for you.
The
You have
train.
been so far from here.
Well, I'm so far at the moment.
More far than that.
Yeah. Well,
No.
not further, but the time. So although I still live in Dublin, because of the traffic,
It's
it's the same. It's the same.
Like from
like-
Redmond to coming here, it takes like in the traffic takes like 40, 45,
Yeah,
50.
I know. So even though I'm twice as far away in
The
Kildare,
traffic is fine. Like
it's the train, so what traffic, And Houston's not too far away to walk to. You could walk there in maybe 20 minutes.
So now where have you found out in which part you're looking?
It's kind of southwest Kildare. It's on the train line. If you look at the map of the train,
Yeah.
it's on the train. The stop the house is beside the train station in Kildare. Not Kildare, but the next town.
I've been to Kildare.
Yeah,
I worked before Kildare, but I have been to Kildare
Yeah.
one time.
yeah.
It's small, but it's
Oh yeah, it's nice.
It's
It's
good.
nice. All right. How did you do with the first one here?
Yeah, I think so.
Electric strength at the location caused by the proton. So you have what's in the middle? One proton, one electron. The distance, 10 to the minus 10. And what do I want first?
E.
E,
Yeah.
which is
Q over bar A.
K, yeah, Q1, Q2 over R squared. I assume you got this okay. What number did you get here? 14.4 newtons per coulomb. Okay, B. Force experienced by the electron. Okay, well, that's also easy. F equals QE. So this should be a pretty small number. What did you get?
2.31 times 10 to the minus 12.
Yep. C. Acceleration. Well, acceleration equals F over
And
so this should be a pretty big number, I think.
yeah,
What you got?
2.53 times 10 to the 12.
Yep.
Is that okay?
Yeah, I was expecting a big number. D, the periodic time. So T equals 2 pi over omega, which is 2 pi, and then, hang on, what's our formula? Omega equals, hang on.
V square.
Hang on, let me think. A equals V squared over R, which equals omega squared R. So that means omega is square root A over R. Yeah, so this would be 2 pi root A over R, which is 2 pi root R over A. So we know the R and the A. Is this how you did it, Iyad?
Yes.
Yeah, what did you get? A small time, I'm imagining.
3.95 times 10 to the minus 11.
Yeah. Okay, so everything is going okay here.
Yeah, okay, so now maybe.
Electric field strength at the proton's location.
Is it
So-
the same as one or?
Here is how strong is the field caused by the proton, whereas in another one it's how strong is the field caused by the electron. So it's like you're looking at the electron's field.
Okay, but I mean.
It's the same,
mathematically it's the same.
yeah, because it's the same charge, isn't it? So you get E equals,
Okay.
oh, rats, I made a mistake here. I wrote Q twice, but I should have just written it once. Yeah, sorry. So it's the same thing. I'll write QP for proton, and this is QE for electron. So you get the same number because it's the same charge. Okay. F. The force experienced by the proton. So F equals QE, and you get the same force. Acceleration now is different. Why? What is different this time that makes the answer different? The mass. So you probably have a tiny number now. What did you get? Was not? What you get? Well, when I say tiny, I'm sorry, I mean compared to what it was previously.
Well, it's not to the power of anything, so I guess it is.
Yes.
I don't know.
Let's have a look. No, that's actually pretty big, but F is tiny. Wait, I thought the F was minus 12. You have minus 18 here.
Did I write minus 18? Okay, that maybe that's.
That might be part of it. No, something's wrong here. F is 2.31 times 10 to the minus 12. I hope not, because I was writing all the answers down.
No, I don't think so. I mean, I follow the same formula and everything.
But this, I wonder if you typed this in wrong, because maybe this should be bigger. What is the constant number for mass of electron?
3 and all 3, yeah.
Yeah, this is wrong here. Guys, this is power 18. Yeah, and the only answer that would affect is this one here, because we didn't use the A anywhere else. Oh no, we used it here. Oh, so this answer is going to be, hang on, this power is going to be wrong here. That's okay, that's okay. And then what's the mass of the proton?
1.
So it's not as big. It's 1,000 times smaller. Okay, that's more like it. Can you retype in the time possibly there? You just need to change your A. It's going to be 2 pi root 10 minus 10 over... Actually, I'll type it in here. 2.53 times root fraction 2 point...
2 pi outside.
Oh, sorry, thank you.
Just minus 14.
That's the only difference?
Yeah.
Okay, fair enough. Minus 14 instead. Right, and is there another part here? No, that's it. Okay. Alright, is everything okay in the first one? So we'll go on to the second one.
Yeah.
Two horizontal plates are held a distance 10 centimeters apart. The voltage is 1000 volts. What charge would you need on 1 gram to keep it balanced between the two? This is 1 gram. Well, you need the force up from the field to equal... If you don't want it to move, what would you need? The force from the field to equal the weight. What's the formula for F? QE. And this one? mg. We're looking for Q. So that's mg over E. What's the formula for E? For parallel plates? V over D. So it's mg D over V. 1 gram is this many kilograms. 10 centimeters, and the voltage is 1,000. Now, do I ask for charge or number of electrons? Yeah, charge. 9.81, and
Can you go back to the question?
I will. This is 0.981 microcoulombs, which I don't like. I want to make it nano, which is 981 nanocoulombs. Back to the question.
How about the part saying that no accelerated between the plates?
If acceleration is 0, then F is 0, meaning it's balanced. If something is not accelerating, it means there's no force acting on it. Exactly.
What is Q equal mg over?
Hey, do you want to go back to the...
mg 0 over V.
Did you get this one?
No, I stopped here.
Where?
Like,
Here?
Yes, I didn't know.
Why? You're on the right track.
No. Okay, so I didn't use the F equals weight.
Okay. What were you thinking?
Okay, I didn't think that I have to make it like the up force equals to down.
Right, you didn't see it as an up equals down problem. Yeah, now see, this is the thing about physics. The problems are easy. Mir, this is the thing about physics. When I do this, I make it look easy, because all I'm saying is this thing equals this thing. And then that's very simple to calculate. The difficulty, what you can't see, is the difficulty in knowing what type of problem it is. So the two of you have trouble seeing that, for example, me saying not accelerate is the same meaning as saying the up force equals the down force. So this is why I say students often do better in chemistry than physics, because when they see me do this, they think, sure, I could have done that. Whereas I think in chemistry, it's a bit more obvious that it's difficult. I don't know, that's my theory. Would you agree or disagree with that?
Yeah.
It's obvious that chemistry is difficult.
Yeah.
It's maybe not obvious that physics is always difficult.
Yeah.
Yeah. Okay, so we'll go on to number 3 now. Yeah. Now number 3 is a hard one. It was an exam question a long time ago. 2 vertical plates are held a distance of 30 centimeters apart at a constant voltage. So I'll draw it as we go along. So what happens here is you have one plate and you have another plate, and they are 30 centimeters apart. And there's a voltage between them, and you don't know what the voltage is. The plate is 10 meters long. Right, so I'm sure you've seen this in Ireland or your home country. You would have a factory and there'd be a big long pipe coming out of it, and we'll put a little colour on the chimney and all the smoke comes out. Do you ever wonder why the pipe is so tall? It doesn't need to be this tall. Like, it could be half the size. I mean, why is it so tall, do you think?
I think because of the air coming out should not be like.
So one reason is you want to keep it away from the people on the ground. Yeah. But another reason is dust particles in the smoke. They have a small charge. If you put plates here and here with an electric field, the dust particles will move towards the plate because it has a small charge, meaning all the dirt in the smoke sticks to the side of the chimney. And then at the end of the day, there's this little machine, I'm not joking, and it has a hammer on it, and it swings back and forth and hits the plates, and all the dust that was on it falls down, and it means that they can capture some of the dirt without releasing it into the air, you know. So this is what we're looking at. We want to know what voltage would we need to make sure we get all the dirt out of the air. Because if the pipe is too short, then the dust will leave before it has time to stick to the plate.
Is it to reduce?
Reduce, yeah, you can't remove everything from it, but at least you can remove, you know what I mean by dust, soot, you know, the sticky black stuff that would stick on buildings and make them look dirty, you know. But you can't, of course, remove other pollutants like the CO2. You would need some more difficult process to remove the CO2, or if there was some other gas in it like methane or ozone or some other stuff like that, it's more difficult to remove. But at least it's quite easy to remove the soot and dust and dirt and gooey black stuff that sticks on things, you know. So what else are we told? We're told the mass of the dust, it's 10 to the minus 5. So it's 10 to the minus 5 coulombs, grams or kilograms? Kilograms. And we're told the charge is 10 to the minus 10. So it doesn't really matter. Let's imagine that it's a negative charge. Well, okay, we'll say it's a positive charge. And let's say in the worst case, the dust starts its life on the left. This is the worst case because it has the most distance to travel to get to the negative plate. So as this moves up the chimney, what will happen? It will start to move to left. And what you want is it to hit the pipe before it leaves. So the minimum is it can stick to the pipe, but it must stick to it at least here or before. So if it particle starts here, it will stick sooner. So I'll just write here, this is the worst case. It starts on the far left and finishes on the far right just before it leaves. Yeah. And what else are we told? We're told also the speed that it moves up at. It moves up at a speed of constant 0.5 meters per second. We don't consider the gravity here because it's moving up at a constant speed in the chimney. The force from the smoke and the force of the gravity cancel, so it just moves steadily up. Okay. If the pipe is 10 meters long and it moves at this speed, how long do we have to capture it? How many seconds?
10 meters long and what?
Half a second is the speed. Half a meter per second. Come on. Yeah, what's the formula?
S over
Yeah.
D.
S over V. You're confusing me.
0.5.
Distance, speed, time. Time is distance over speed.
Distance over speed.
Yeah. Sorry.
Over 0.5.
Yeah.
20.
20 seconds. Yeah? So you have 20 seconds to capture it. Okay? So you have 20 seconds. Let's look at it moving to the left. Okay? You have UVATF. Now this is horizontal now. Horizontal. What's the U? Horizontally. 0. The V, we don't know. The A, we don't know. The T, we do know. We have 10 seconds to capture it as it moves horizontally. And S, we do know it's 0.3. Can we work out the A? Yeah.
Yes.
What formula? No, here. B squared S equals UT plus a half AT squared. So the A is 2S over T squared. So the A is 0.6 over 400. What's that, please, ES, since you have the calculator handy?
1.5
meters per second. Okay. We have F equals ma. What is causing the force in the electric field? What is the formula for the force in an electric field? QE. QE. Do we know the Q? Yeah. Do we know the E? No. But we can kind of work it out. What's the formula for E? V over D. Do we know the M? Yeah. Do we know the A? Yeah. So let's recap what we know. Q? Yes. V? No. D? Yes. M? Yes. A? Yes. And what am I looking for? So V equals MAD, MAD, over Q. So let's calculate that. M, 10 to the minus 5. A, 1.5 times 10 to the minus 2. Minus 3. D, no, we're looking horizontally, because it's moving between the plates horizontally. So what is it? Yeah, and Q, 10 to the minus 10. So the voltage needs to be 45 volts. Yeah. I don't think I made this realistic, because usually these things are kilovolts, I guess, but 45, well, no, 45 is okay, I suppose. So if you had a 45 volt between the plates, this would cause an electric field strong enough to make sure the dust accelerates hard enough to hit the plate within 20 seconds, because 20 seconds is your time limit to capture it before it escapes. Imagine, please, that the charge was smaller, guys. If the charge was smaller, do we need a bigger or smaller voltage?
If the charge is small, we need a bigger voltage.
Yeah, very good. We need a bigger voltage, yeah. And what about if the dust was heavier? Well, the voltage, I mean to say. Do we need a bigger or smaller voltage? We need a bigger voltage, okay? So, what you would need to do as an engineer designing this pipe, the voltage you would have to use. You see, the pipe, you don't really have too much choice about the pipe, because these are constructed by the builders, you know, they build the pipe, the architect, you know, but as the sort of clean energy engineer, you can say, well, if you put the plates here and have a voltage strong enough, you can capture some of it. So the voltage you would need as a minimum would need to be the mass times the acceleration times the distance over Q. And you need to use what you feel is the smallest mass that you could have of a dust particle. So this mass would be the minimum mass you think you can imagine the dust could be, because maybe dust has to be at least so big. The D and the A you have less control over, and the Q, you imagine it being the biggest. Sorry, I said that wrong. You have to imagine the mass being as big as possible, because you imagine the worst case always. So the worst case is a big mass and a small charge. So you might have to go away and do some research on the dust particles. You know, you'll have to Google, how big could a dust particle be? Or what's the smallest charge it could have? You know? And then maybe you want to double that answer to be safe. You get it? You don't want to make the voltage bigger than it needs to be, because number one, that will make it more expensive for the company, and number two, that makes it unsafer. You know, high voltages are dangerous. So, you know, it's a balance between all different factors. I like these types of physics problems because these are real practical problems. You know, when you go on to do engineering, you know, and then you go on to work environment, you know, this is the type of thing you'd have to think about. Except, of course, you will have new problems that you haven't seen before. You know, this is an old problem. You know, this has been around for a long time because it's not very difficult. You just need two plates and a current, you know. But it's a good first example of practical engineering. You're civil engineering, so you're mechanical and electrical? Maybe. And what was that now? Mechatronics. I don't know what this would be in. You might do something like this in all engineering, but civil maybe. But anybody doing, you know, that new clean engineering or green engineering, you know, like environmental engineering, like engineering for the future, you know, like electric cars and solar panels, they definitely do something like this. Okay, Ruth Sharif, we're finished. Yes. What class have you got now?
Nothing.
So what's the rush?